This series of videos will be about Section 3.3, Piecewise Defined Functions and Power Functions. This is from College Algebra in Context. Times a function is defined in pieces for different intervals of the domain. And notice it's intervals of the domain. We'll have an example coming up right here. This table gives the local postage rates as a function of weight for medium mail. Write a step function that gives the postage P as a function of the weight in pounds. And you can see between 0 and 1 pounds, it's one rate, and then it changes depending on how many pounds they are. So to write this piecewise function, we have, and this is going to have 5 pieces. So we have a bunch. The rate, the y value, is 2.38 when x is greater than 0, less than or equal to 1. So between 0 and 1. Then it's $2.77, $2.77, if it's greater than 1, less than or equal to 2. So from 1 up to 2 pounds. The rate is 3.16 from 2 is less than x is less than or equal to 3, and it is 3.55, 3 is less than x is less than or equal to 4, and it's 3.94, 4 is less than x less than or equal to 5. So we might ask the question, let's say we have a package that weighs 3.27 pounds. How much would the postage rate be? Well, that's between 3 and 4 pounds, so the postage rate would be $3.55. Notice there's only one answer for that, because we went where it is. Where does this x fit in the domain? Where does it fit over here? And then we only use that. I'm going to try to graph this function. Well, the number in the bottom, 0, 1, 2, 3, 4, 5. And I think I can do 1, 2, 3, $4 up the side. So it's $2.38, so 2.38 would be just over a third here from 0, so I'll put a circle, and then I'll put a dot here at 1 and fill in between. So it's between 0 and 1 is this much. 277 is going to be about right here. 1 pound will still do this. So I'll go to 2 pounds. And 2 pounds, there's my postage rate. Between 2 and 3 pounds, $3.16 will be approximately here. It's open because I've already got it filled in here. So this says it starts there, starts right after the 2 pounds. 355. So right here, go straight across to the 4, and then 394 will be almost 4, but not quite. Over 2. That would be my piecewise function. And you can see that 327 that we did before would come up right here with this $2.55. This one, they give us the graph, and we have to figure out the piecewise function. The cost for weekend service calls at Aerotech Services shown by the graph. Write a piecewise function that represents the cost for service during the first 5 hours as defined by the graph. Well, we're looking for a cost, and I have 3 steps, so let's make room for 3 rows, it's $330 up to 1 hour. From 0 up to the 1 hour. This is solid filled in. It's $550 if 1 is less than x, less than or equal to 2. So if it takes up to $2, up to 2 hours, it's $5.50. And it's $770 if it's between 2 hours up to 5 hours. It's greater than 2 hours up to 5 hours. This then becomes my piecewise function. So if it took, let's say the repair took 1.5 hours. Well, 1.5 hours would fall in here, and it would cost $5.50, or $550. An absolute value function. If x equals a, if absolute value equals a and a is greater than 0, then either x equals a or x equals negative a. There's no solution if the absolute value of x is a and x is a negative. There's no solution when a is negative. And x equals 0 has the solution. Absolute value of x equals 0 just has one solution, x equals 0. Solve some absolute value functions. So we have an absolute value equals 16. Well, that we know that means either the number in the absolute value equals 16, or that what's in the absolute value equals negative 16. So solving that, either x equals 20, or x equals negative 12. Those are my two solutions. And this one, again, I've got the absolute value equals 10. So what's in the absolute value? 3x minus 5 either equals 10 or 3x minus 5 equals negative 10, because the absolute value of negative 10 would be 10. So 3x equals 15 and x equals 5, or 3x equals negative 5 and x equals negative 5/3. Those are the two solutions. An absolute value solution, unless it equals 0, usually has two solutions. Two solutions.